our topic is Euclid division lemma. Okay, and this Euclid division lemma is included in your first chapter, that is in for class 10, first chapter in number system, Euclid division lemma. That is very important. And to know about Euclid division lemma, you have to know first of all the meaning of lemma. First of all, we need to know the meaning of lemma. Okay, the meaning of lemma is nothing but, this is one kind of proven statement. This statement, it is used for to prove any theorem. Lemma is what? Lemma is a proven statement which is used for to prove any theorem. Okay, that is known as lemma. Okay, so Euclid division lemma, that means how to divide, or related to division method. Euclid has given one lemma, that is Euclid division lemma. Okay, so first of all we need to know about basic concepts of division. Suppose we are dividing 7 by 2, then it will be what? Whenever we are dividing 7 by 2, then what will be our quotient? 2 3s are 6 and the remainder is 1. Clear? Okay, let's solve another one. Suppose we are having 12 dividing by, suppose 4. What I can write? 4 3s are 12, remainder is 0. See one thing, from this condition we can say one thing, we can write one thing. This 7, that means dividend can be written as 7 is equal to, can I write 2 into 3 plus 1? This, whether 7 can be written as this 2 into 3 plus 1. See, 2 into 3 6, 6 plus 1 7, so 7 equal to 7. Okay, now come to this point. So in this case also we can write like this, 12 can be written as 4 into 3 plus 0. Check once, 4 3 is 12 plus 0 is 12. Clear? Okay, so that means in that case what we can say, this 7 is what? 7 is actually dividend, is it? Okay, then 2 is what? 2 is nothing but your divisor. Clear? And into, here into is there. This 3 is nothing but, 3 is what? Quotient. Okay, so let me write this within the bracket, and next plus, this 1 is what? This 1 is nothing but your remainder. Okay, see what I can write, what I have written. 7 is equal to 2 into 3 plus 1, or 12 equal to 4 into 3 plus 0. Same thing. For this case, 12 is dividend, divisor is what? 4, and the quotient is 3, and the remainder is 0. So in every case, whenever you will divide, in that case you can write this relation. Dividend is equal to divisor into quotient plus remainder. Okay, see, now the condition for remainder. Actually this remainder, in this case this remainder always must be less than the divisor. See, whenever you will get the remainder, that remainder always must be less than the divisor. Clear? Otherwise, if it is equal or more than the divisor, then it will divide again. So that is why the remainder always must be less than the divisor. Clear? And the remainder may be, sometimes may be remainder 0. So what we can write here, this remainder, okay, this remainder may be what? May be 0 or less than divisor. Clear? This remainder must be maybe 0 or less than the divisor. Right. Okay, so if we consider this dividend is equal to a, if we consider dividend is equal to a and the divisor suppose it is b and the quotient is suppose q, so I can write bq plus this remainder. If I write this remainder is equal to r, then we can write a is equal to bq plus r. Clear? And this r means remainder, then the remainder, the condition of remainder, it may be equal to 0 or this is less than what? Less than the divisor. Here divisor I have written b. So this is your condition. So if I summarize all these things, so I can write a is equal to bq plus r, where I can write 0 less equal to r. It means the remainder is equal to 0 or greater than 0 and should not be exceed our divisor. So this is our main condition. So a is equal to bq plus r, where 0 less equal to r less than b. Clear? This concept, that is dividend is equal to divisor into quotient plus remainder, this concept has given by our mathematician Euclid, and this statement is known as Euclid's division lemma. Is that clear? Okay, so Euclid's division lemma, this is actually only mathematical statement. Okay, so we need to write the statement of Euclid division lemma. Okay, so let me write the statement of Euclid division lemma. See, in this case, this for this division, this 7 and this 2, this 7 is must be positive integer. If the 7 is positive integer, then definitely you will get this divisor and the quotient is what? This divisor and the quotient both are positive integers. Okay, so while dividing 7 by 2, whether you will get the quotient as 3 and the remainder as 1, except these two things, whether you will get any other values of quotient and remainder. Can it be divisible while dividing 7 by 2? Can it be divisible 2 into 4 something, 2 into 4? Not like this, no? So that is why here this quotient and the remainder must be unique. Unique means except this 3 and 1, you will never get any values of quotient and remainder for this case. Even you can think about this case also. In this case, while dividing 12 by 4, you will get only the quotient as 3, not other than 3, and remainder is 0. That means we can say that this quotient and the remainder both are unique on the depends on divisor and dividend. Clear? Okay, so if I state Euclid division lemma, so what we can write? Statement: for two positive integer a and b, there exist two unique integers q and r, such that a is equal to bq plus r, where 0 less equal to r less than b. This is the statement of Euclid division lemma. Clear? So you can state in this way that for two positive integers a and b, there exist two unique integers q and r, such that a is equal to bq plus r, 0 less equal to r less than b. This is your Euclid division lemma statement and the brief discussions. That's all about Euclid division lemma. Okay.